Hello class. Welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today, we are going to learn about the structure of three-phase asynchronous motors. We will mainly discuss three aspects: an overview, classification, and structure of three-phase asynchronous motors. Asynchronous motors are widely used in the industrial field and in our daily lives to drive mechanical devices and serve humanity. I have listed three important application scenarios, such as the power source for new energy electric vehicles, industrial robot arms on assembly lines, and household washing machines. All of these rely on electric motors. What are its advantages? Compared to other types of motors, asynchronous motors have a relatively simple structure. For example, a DC motor consists of brushes and a commutator, but asynchronous motors do not have these mechanical constraints. Asynchronous motors have a higher speed compared to DC motors. They are easy to manufacture, cost-effective, and have good reliability and durability. Additionally, their operating efficiency is relatively high. It is precisely because of these advantages that more than 2/3 of motors used in the industrial field are AC motors as the driving force. Of course, asynchronous motors also have some disadvantages, such as power factor difference. When operating, asynchronous motors must absorb lagging reactive power from the power grid, resulting in a power factor less than 1. Classification of asynchronous motors. Asynchronous motors are usually classified based on the number of stator winding phases and rotor structure. Based on the number of stator winding phases, they can be divided into single-phase asynchronous motors and three-phase asynchronous motors. Based on the rotor structure, they can be classified as squirrel cage asynchronous motors and wound rotor asynchronous motors. Now, let's learn about the structure of asynchronous motors. This is a disassembled, three-phase squirrel cage asynchronous motor. The diagram below shows the disassembled parts of a three-phase asynchronous motor, which mainly consists of a stationary stator. This is composed of a stator core, stator windings, a motor frame, and a rotating rotor. This is composed of a rotor core, rotor windings, cooling fans, and an air gap. First, let's look at the stator, which is mainly composed of a stator core, stator windings, and a motor frame. The stator core is typically made by stacking insulated silicon steel sheets with a thickness of 0.35 mm to 0.5 mm. Why is it stacked? It is mainly to reduce hysteresis and eddy current losses. It forms the magnetic circuit part of the motor. From the diagram, you can see the stamped stator silicon steel sheets, and the second figure shows the stacked stator core. The third figure is a representation of the stator winding, embedded in the inner circular groove of the stator core. The last figure shows a complete stator core and winding structure. Now let's introduce the stator winding. The stator winding is usually embedded in the slots of the stator core, and it is the circuit part of the motor. When three-phase alternating current flows through it, it generates a rotating magnetic field. This is a wire model for winding resistance. The second figure shows a completed coil. The third figure shows the winding with insulated tie straps. The last figure shows the final manual shaping, which refers to the process of shaping and arranging the winding. The modernized motor offline process needs to be emphasized. According to the form of the motor stator, there are many automatic winding and automatic offloading. Automatic shaping devices greatly reduce labor and improve reliability. Now let's take a look at the motor base. The motor base is mainly used to fix the stator core, the front and rear end covers, and support the rotor, providing protection and heat dissipation. After introducing the stator, let's take a look at the motor rotor. The rotor is mainly composed of a shaft, rotor core, rotor winding, and other components. The rotor core is part of the motor's magnetic circuit. It is also made of 0.5 mm thick silicon steel sheets, similar to the stator core. The rotor core is fixed on the shaft or rotor support, and the whole rotor has a cylindrical shape. Then comes the rotor winding. Let's first introduce the squirrel cage rotor. As shown in the figure, the left side illustrates the structure of the entire squirrel cage rotor. The figure on the right shows the rotor core and shaft-removed squirrel cage rotor. We can see that. The squirrel cage rotor consists of rotor bars inserted into the slots of the rotor core and short-circuited at both ends with two end rings. This forms a polyphase symmetrical short-circuited winding. For asynchronous motors, in addition to the squirrel cage structure, there is another type of rotor structure called the wound rotor, as shown in the diagram. It consists of a three-phase symmetrical winding and a rotor core. The winding method for the three-phase winding is the same as that of the stator three-phase winding. Since there are three-phase windings in the rotor, it is necessary to introduce the external circuit into the rotor winding through slip rings and brushes. Next, let's learn about a concept called air gap. Because the motor rotor needs to rotate, there is a gap between the stator and the rotor. This gap is called the air gap of the motor. The air gap of an AC induction motor is generally 0.52 mm. The size of the air gap has a great impact on the performance of AC asynchronous motors. If the air gap is too small, it will make motor assembly difficult and decrease the starting performance, making the operation unreliable. If the air gap is too large, it will cause a decrease in power factor during motor operation. The concepts of air gap, composite magnetic field, and electromagnetic torque, which we will mention later, are closely related to the air gap. That's all for today's lesson. Thanks for watching.